Hello YouTube, this is Prashant. In today's set of questions, we're going to be discussing two questions from the topic Redox Reactions. So let's start the thing off. So the first question here is going to be a very straightforward question. Hydrogen peroxide is used as an oxidizing agent in which among the following four reactions over here? So let's have a look at the reactions over here. So when hydrogen peroxide is going to be acting as an oxidizing agent, what does that really mean? So when H2O2 acts as an oxidizing agent, some other substance has to undergo oxidation, meaning H2O2 should undergo reduction and it should end up becoming H2O. So let's quickly analyze what is the simple aspect over here. In hydrogen peroxide, each oxygen is present in a -1 oxidation state. In water, it is present in a -2 oxidation state. Of course, when it has to go from -1 to -2, this basically means that it is going to be undergoing reduction in this particular case over here. Alright, so let's have a look at the reactions over here. In the first reaction over here, we can see that HOCl is basically going to be reacting with it, and when HOCl is going to be reacting with it over here in option A, H2O2 is actually becoming O2 in the process over here. So when H2O2 is becoming O2 here, is that the only thing which is happening here? Have a look here. In this reaction here, HOCl is basically becoming Cl minus, right? So if HOCl is becoming Cl minus, chlorine is present in +1 oxidation state over here. So chlorine, which is present in +1 oxidation state, is actually going to become Cl minus. So chlorine is undergoing reduction here for sure, which means the HOCl is actually acting as the oxidizing agent in this actual reaction over here. It is not the H2O2 which is acting as the oxidizing agent. Yes, H2O2 is also partially decomposing to actually effectively become the H2O, which becomes part of the H3O plus, but it could also be that there was water present and they didn't mention it in the reaction over there. So in essence, when something is undergoing reduction and something is behaving as an oxidizing agent, it can behave as an oxidizing agent only when something else is capable of behaving as a reducing agent. So in this reaction, what is actually happening is H2O2 is actually becoming oxygen gas, meaning it is undergoing oxidation here, meaning it is acting as a reducing agent. So first option is going to be not correct over here. Now let's look at option Bombay here. In option Bombay, look at what's happening here. You're going to be having I2 becoming I minus. Correct. So iodine is going to be going from oxidation state 0 to -1. Right. So at the same time, what else is happening over here? You're also having one other part happening in this particular case here, which is that, well, this guy is acting as a reducing agent or oxidizing agent. This fellow is undergoing reduction because it's going from 0 to -1. So this guy is acting as oxidizing agent. So same logic applies over here as the previous case. In the sense, we are going to be having H2O2 forced into behaving as a reducing agent in this case, meaning the H2O2 is what is producing the oxygen gas in the reaction over here. Meaning this Bombay option is also wrong over here. So in this second reaction as well, we are going to be having H2O2 actually acting as a reducing agent here, not an oxidizing agent. Okay, let's look at the third option over here. In the third option over here, what is happening is MnO4 minus is effectively becoming MnO2. Pay attention to the part there, MnO4 minus becoming MnO2. So manganese is in +7 oxidation state in the MnO4 minus one, and it is going to a +4 oxidation state. So if it's going from a +7 to a +4, obviously it has to gain 3 electrons in the process. Again, gaining of electrons is going to be reduction. How can you remember that reduction is gaining of electrons? Simple thing, remember it as oil rig. So rig basically is going to be reduction is gaining electrons. Oil effectively stands for oxidation is losing electrons. So if you are able to remember this simple mnemonic, you can automatically figure out whether it is undergoing oxidation or reduction as necessary. So in this case, you're going to be having MnO4 minus undergoing reduction, which means MnO4 minus is going to be the oxidizing agent in this reaction over here. We have already concluded option A and option B are wrong. So what was the reason why we concluded both option A and option B were wrong? Same reason as earlier. when something is acting as an oxidizing agent, something else has to act as a reducing agent over there. Meaning in this reaction also H2O2 is forced into acting as a reducing agent, and H2O2 is the one which is producing the oxygen which is produced in the product over here. Meaning option C is also wrong for this particular question over here. Let's look at the last option over here. This is a very famous reaction actually. You guys might have heard about old oil paintings. When it comes to these old oil paintings, the idea here is in these old oil paintings, what happens is, well, in say Van Gogh's time, they used to use white paint, which used to be lead based white paint. So when it is going to be lead based white paint, usually it used to be lead carbonate or some other lead based white paint, which basically means a compound made of lead which is white in color. What happens to that particular lead substance, lead paint over there is, when it is going to be present for a very long period of time, it starts to slowly become black. Why does that become black? Very simply put, the lead part over there will end up changing, whatever compound of lead was present will end up changing into PBS over time. And lead sulfide is actually black in color. There is a very simple technique by which, how to say, professionals, very talented professionals who are also artists, effectively make sure that the color of the paint changes back to white. How do they do that? They end up taking hydrogen peroxide and they paint over the parts where the blackening has started happening, so that in those parts the PBS will undergo oxidation to become PbSO4. This PbSO4 is actually a white colored precipitate of lead again. So in the last reaction, what is actually happening is hydrogen peroxide, well, look at this reaction here, PBS becomes PbSO4. We'll come to the hydrogen peroxide part, but let's quickly go to the PBS becoming PbSO4 part here. PBS is going to be having sulfur in -2, and in PbSO4 sulfur is present in +6, meaning in this reaction, Delhi reaction, or the reaction of paint basically, old paint basically being retouched to make it proper again, in that reaction PBS is becoming PbSO4, meaning in that reaction we are actually going to be having the black color changing into white color by oxidation of the PBS in this particular case here, meaning this is undergoing oxidation, meaning this guy is acting as a reducing agent, meaning something else has to act as an oxidizing agent. What is the only other thing which is available here? Of course, we are going to be having hydrogen peroxide as the only other thing over here, which basically is going to be acting as the oxidizing agent here, and it ends up becoming water in this particular reaction here. So overall, in this last reaction alone, hydrogen peroxide is going to be acting as an oxidizing agent in this particular case over here. Alright, so what does this tell us? This tells us that the correct answer for this question is actually option D, and whichever student I picked this question from has actually marked the wrong answer. Alright, so this was question number 1 for today. Now let's have a look at one more question involving redox reactions. Now, this is going to be the second question we are going to be looking at for today. So in this second question, let's have a look at this question. Which of the following options are correct for the reaction? So in this reaction, what is being asked over here? They have given us a reaction. AuCN twice -1 aqueous plus zinc solid is going to be giving us 2 gold plus ZnCN 4 times -2 aqueous. This is actually the reaction which is involved in, well, what do you think? Take a guess. Exactly. This is going to be the reaction which is involved in extraction of gold. Alright. So when we are going to be looking at gold and we are interested in extracting gold, have you guys seen Mechanis Gold or any old movie where they show mining of gold? Or in our current movies also, for instance, KGF is about well, a gold mine and the instances and the things which happen near there, the Kolar gold fields basically. So when you're going to be considering extraction of gold, gold is present in pure form but with a lot of impurities like sand and of course rocks, because gold is like a thin thing inside, a huge piece of rock. How do we extract it out? We powder the entire rock and we try to dissolve only the gold over there using cyanide. When I say cyanide, we'll usually be using potassium cyanide, of course in the presence of air. such that the gold present over there in the presence of the KCN and oxygen gas will end up dissolving to form the complex given over here, AuCN twice minus 1. So when it does this reaction here, we have got the gold now in soluble form, it is now in solution. Once you have got it in solution, obviously the meaning of the gold is going to be only when it is properly in pure form and you are able to get it in solid. Having it in a solution, nobody will understand it is gold, na? So the simple principle here which we are going to be doing over here is we recover the gold back using zinc in this case here. That is the reaction which is present in this question over here. So have a look at it over here. What is actually happening is gold is present in which oxidation state over here? It is present in +1 oxidation state over here. Zinc is initially present in an oxidation state 0 in this particular reaction here. At the product here, what is happening? Gold is now back to 0 and the zinc is going to be present as a complex here in the form of zinc 2+. Of course, the complex is going to be the one which is shown in the equation here. This complex is of course going to be ZnCN4 times 2-. And in this complex, the zinc is present in a +2 oxidation state here. So in effect, what is the reaction which is happening over there? In effect, the reaction which is actually happening in the given reaction over there is gold in +1 is reacting with zinc in oxidation state 0 to become gold in 0 and zinc in oxidation state +2. Why does this happen? Of course, because zinc is much more reactive than gold, and more importantly in this particular question here and in this actual reaction, zinc is actually going to be forming a more stable complex, which is why this reaction actually happens. This entire extraction of gold process over here is actually going to be having a very interesting name. It is called MacArthur-Forrest cyanide leaching. Yes, it is a large name, MacArthur-Forrest cyanide leaching. Leaching is basically the chemical method by which we dissolve the useful thing and then we recover it back again. I hope you guys had fun with these 2 questions for today. I'll see you guys in the next question session. Take care till then, guys. Thank you very much. Have a nice day. Bye bye.